Good morning. Welcome to the PENC Virtual Raleigh Seminar. My name is Katie Cox, the PENC Membership Director. I will be serving today as the moderator. If you have any technical issues today, please use the chat box and I will do my best to assist you. We will take questions at a couple different points during the presentation today. Feel free to type those in using the questions box or the chat box. I will be monitoring that and will ask the questions out loud to our speakers. I'd like to take a moment and thank our sponsors. Without you, this would not be possible. Our title sponsor is the NC Electric Cooperative, so thank you very much for your support of the PENC Raleigh Seminar. Today's speakers are Greg Canellis and Justin Ballard. Mr. Canellis is a professional engineer with over 13 years of experience in environmental consulting. His experience includes assessment and remediation of contaminated sites, environmental permitting and compliance support, property transaction due diligence, and Brownfields property redevelopment assistance. Mr. Ballard is a licensed geologist with over 14 years of experience in the field of contamination assessment and remediation. His experience includes assessment, remediation, and monitoring of sites impacted with chlorinated solvents, petroleum, hydrocarbons, metals, and other contaminants. He has led numerous properties through the federal and North Carolina Brownfields programs and has a strong background in property transaction due diligence. And we're going to start today with a poll question. So you will see it up on your screen. So go ahead, I will give you about 30 seconds to answer that. All right, last answers coming through. I'm going to go ahead and close the poll. And you can see the results there. About 69% are familiar, 31% do not know what it is. All right, and now I'll turn it over to Justin.
Thanks, Katie. Glad to be virtually here with everyone this morning. I'm getting a little tired of saying that word, but before we get into this topic, I'm going to try to lend some perspective. I know 30% of you, don't know what a phase one is, so maybe this will be helpful. We as scientists and engineers are typically uncomfortable in the abstract world. We like certainty, we like fundamentals, and in most cases, we like to understand the rules and regulations that govern the field that we work in. So the environmental field really is just no different. It's in fact littered with tons of federal, state, and even local law. And so these laws can change, with updates and new toxicological information or even scientific practice. So as it pertains to development projects and property transactions, navigating the environmental field is a necessary step to ensure risk transparency. And so with the understanding that many of you may not be directly involved with these types of environmental projects, Greg and I have tried our best to keep this presentation as engaging as possible. Questions are definitely welcome. Hopefully we'll have enough time to address them after each of the three sections that we've separated this presentation out into. And so please submit questions to Katie as she suggested via the webinar interface as we go along. If you do not know what a phase one ESA is, or you've never heard of the NC Brownfields program, I hope you'll get a lot out of the next hour. If you have familiarity with these topics, it's also our hope that will contribute to that knowledge base. So those of you that have been involved with phase one or phase one environmental site assessments, or have ever even tried to read one, know that every single one is different and filled with nuances. Because of this variability, and for the purpose of this webinar, it'll be helpful to have a strong foundation in the why and the what questions, and not so much the how question. So before we get into what a phase one environmental site assessment is, it's important to understand, why are they performed in the first case? In most cases, the answer to that question is there a reason to be concerned about the environmental integrity of this specific piece of real estate at this point in time? And the reason, why we ask ourselves that question is rooted in a series of federal laws. In 1976, the Resource Conservation And Recovery Act comes into place, which basically creates the framework for the proper management of hazardous and non-hazardous solid waste. And specifically, it gives EPA the authority to control hazardous waste from cradle to grave, including the generation, transportation, treatment, storage, and disposal of hazardous waste. In 1986, there was an amendment that was passed that actually expanded EPA's ability to address environmental problems that could be the result from underground storage tanks, petroleum tanks at gas stations, essentially, and any other tanks that might contain hazardous substances. So fast forward to 1980, and you have the Comprehensive Environmental Response, Compensation, and Liability Act. This is also known as CERCLA, or most of you are probably more aware of the commonly used term Superfund. So this created a tax on chemical and petroleum industries and provided broad federal authority to respond directly to releases or threatened releases of hazardous substances that may endanger public health or the environment. The law also established prohibitions and requirements concerning closed and abandoned hazardous waste sites. It addressed liability for responsible parties tied to release of hazardous waste at these sites, and through taxation, established a trust fund to provide the cleanup when no responsible party could be identified. From a phase one legal perspective, like, this is the law. So, another way to think about RCRA versus CERCLA or Superfund is that RCRA is prospective and compliance-based management, whereas Superfund is retrospective management and asset-based liability. In 1986, Superfund Amendments and Reauthorization Act, commonly known as SARA, came into place, which required Superfund actions to consider the standards and requirements found in other state and federal environmental laws. And so they're kind of merging these laws together. It also encouraged greater citizen participation in making decisions on how sites should be cleaned up, and it increased the size of the trust fund through that taxation I mentioned. This is also where you start to see further clarification of the concept of acquisition without knowledge. In other words, there's no excuse not to know. There's no platform for plausible deniability. In 2002, the Small Business Liability Relief and Brownfields Revitalization Act was passed. This is known as kind of the Brownfields Law. And it came into effect, which amended CERCLA by providing funds to assess and clean up brownfield sites. It also provided funds to enhance state and tribal response programs, and then it clarified CERCLA liability protections. And so this is, again, kind of you're merging these laws together, and this CERCLA liability protection update was kind of, where the phase one process got most of its meat, as we know it today. So if you fast forward to 2005, you have EPA's issuance of the All Appropriate Inquiries, which is their interpretation of a process for evaluating a property's environmental conditions and assessing potential liability for any contamination it may have. Now, all appropriate inquiries must be conducted to obtain certain protections from liability under CERCLA. And at the same time, we see the fourth ASTM 1527 amendments come into play, the 1527-05. ASTM, while they're not, the EPA or the federal government, they've been issuing technical standards since the late 1800s. And if you ask them why that is, they will respond with it's their record with the courts. And so, EPA determined ultimately that their standard is compliant with their all appropriate inquiries. So how are these laws applicable to real property? And as a side note, I'm now trying not to get distracted. I'm now noticing that the completely unapplicable hand and arrow little design that I use, it just doesn't really make sense here. But nonetheless, CERCLA provides protection from liability for certain landowners and prospective purchasers of real property. This could include innocent landowners, contiguous property owners, bona fide prospective purchasers who may have bought property without knowledge of the contamination that's there, and also government entities that acquire property through eminent domain. And so to qualify for landowner liability defense, a defendant must have undertaken at the time of acquisition all appropriate inquiry into the previous ownership and uses of the property consistent with good commercial and customary practice. In other words, they must have conducted a phase 1 environmental site assessment. So what is EPA's all appropriate inquiries? It could basically be summarized in 10 points. It must be performed by an environmental professional. It must include interviews with people knowledgeable about the property. It must also include review of historical and environmental related information, as well as physical observation of the property and the property surroundings. Finally, it must allow for a person who wishes to seek the liability protection, and this is, they're called the quote unquote user of the phase 1 ESA, provides them the ability to provide additional property information as well as comment on the purchase price, relative to fair market value. And the user of that phase 1 ESA must comply with all these points, again, using good commercial and customary practice, i.e. ASTM standards. So to round out the answer for why are phase 1 ESAs performed, it's usually to qualify for CERCLA landowner liability protection. However, other reasons could also apply. This could include, someone's desire to understand potential environmental impacts on a property that they already own, or maybe this person wishes to have a phase 1 performed for the purpose of negotiating purchase terms with a potential buyer, or if they're looking at a property as a seller. It's not required by law, so there's definitely some scenarios where you might have one completed just to get visibility on certain issues, or perhaps the property owner is looking to refinance debt, and so their lender has required a phase 1 to be performed. So all these situations are in fact possible. So now that we've answered the why do we perform a phase 1 ESA question, we can then kind of go to the what is a phase 1 ESA. And as I mentioned before, the purpose of ASTM, or the ASTM standard, is to satisfy EPA's all appropriate inquiries. In order to do this, one must study the current and past uses of a property to evaluate the likelihood that certain environmental conditions are present. In other words, this point 3, one must identify recognized environmental conditions. And what these are, and as the standard defines them, are the presence or likely presence of any hazardous substance or petroleum product in, on, or at a property. And this can be in any of 3 situations. It could be due to any release to the environment, under conditions indicative of a release to the environment, or under conditions that pose a material threat of a future release to the environment. So how do you comply, with the standard? You must complete 6 parts. You must review government records, physical setting records, historical land use records. You must also conduct site reconnaissance and interviews. You must provide a report that documents, your findings and what you did. These first 3 items that are shown here on the screen are typically obtained through an environmental database report, such as EDR, the more common one, but there's also a few other ones, such as ARIS. And so some general rules for government records include that, the records must be reasonably ascertainable, and the commercial services can be approved also as sources of government records, as long as the information is current, within, I think it's 90 days of the release date. The physical setting records review is typically a review of like a USGS topographic map or an equivalent map to get gradient information for the site. Is contamination from an up gradient property coming on to your property, or are you spreading contamination to a property that's down gradient of you? Other information may also be required if that contaminant migration is likely or customarily included by local practice. So there's some local laws that sometimes come into effect here, not just state, not just federal. Your historical land use records review that identifies prior uses and surrounding area uses. This can be general unless your site has an industrial use. If it's been developed for 150 years and it's gone from dry cleaning to textiles to manufacturing to research and development, you've got to really understand when it was first developed and what's happened up through present day. It might be a house right now, but that doesn't mean that it wasn't a manufacturing facility 50 years ago. So other sources that can contribute to this knowledge base, might be aerial photographs or property taxes, building department records, city directories, sandboard maps or fire insurance maps, and even like land title and zoning records. So as part of this database search, these EDRs, these ARISs do, a list of sites like within the vicinity of the subject site. So they search for, national priority list sites. These are your federal Superfund sites. These are typically the worst of the worst. They also do circlist sites, which might be in the federal database, but it's not yet a Superfund site, or maybe EPA has already ruled it out as being a Superfund site, but it's still in that database. Or it might be a site where no further remedial action is planned, so cleanup has gone on, or it might be a facility that is subject to corrective action, this CORAX listing, or it might be a hazardous waste treatment, storage, or disposal facility. So these database reports do a lot of the legwork for the environmental professionals to kind of identify potential facilities surrounding the property or even on it, if it's applicable, to kind of help the environmental professional understand, what's in the site vicinity and how does it impact the subject site. It also does this for state led investigations and properties. These are where your state brownfield sites, might pop up on the database listing, or your underground storage tank sites, your gas stations, which everybody knows that these are everywhere. And even if they're, the downtown property doesn't have a gas station on it, doesn't mean that it didn't have one there 20 years ago. So getting back to those 6 elements I mentioned, these are the last 3 that round it out. So for site reconnaissance, when you conduct your actual site visit, the purpose is to document uses and conditions of the land and the structures and the periphery of the property. You also want to observe all interior structures, which could include, maintenance and repair areas, boiler rooms, chemical storage areas. You're looking for storage tanks, underground storage tanks, above ground storage tanks, drums, totes, anything that could be evidence of use of hazardous substances or petroleum products. From an exterior standpoint, you're looking for pits, ponds, lagoons, stained soil or distressed vegetation, solid waste, dumping debris, fill dirt from an unknown origin. Did somebody bring dirt on this site for grading purposes, or just to waste it because you had a low-lying area? Where did that fill come from? You're looking for evidence of wastewater infrastructure, water supply wells, and septic systems. For the interviews portion, you need to conduct these interviews with past and present owners if possible. What do they know that could be helpful to your investigation? If you can find a maintenance person, they can potentially identify the more applicable environmental related information. These interviews are important, but are often difficult to perform due to a number of challenges. Maybe that maintenance person just doesn't feel comfortable, being interviewed. You're doing a phase 1 because you're interested in buying the property. The maintenance person, works for the seller of the property. And so the last thing they want to do is give you the information that you're looking for to say, hey, this has got a problem, and it just kind of opens up Pandora's box. So these these can be challenging, but according to the standard, are a part of fulfilling your obligations of the phase one. So once you have completed your records review and your site reconnaissance and your interviews, you're now at a point where you have to make decisions, based on your findings. This flow chart from ASTM kind of walks you through how that decision process might look. As an example, let's say your site has a corroded tank that's not necessarily within secondary containment. And let's say that tank looks like it might hemorrhage, at any point. You may conclude that there's a material threat of a future release, to the environment. And while you might not know what's in the tank, you know that the current site is used as a fleet, vehicle maintenance facility. So from those facts, you could reasonably ascertain that the tank contains petroleum, and so therefore you deduce that the tank represents a wreck. The tank has not spilled its contents, but there's a material threat of future release because it looked like it could go at any time. And so you go right from there to, yes, you've got a recognized environmental condition. Or if there's no tank, but there's a massive amount of, stained soil or distressed, vegetation in the area of the tank, you no longer have a material threat of a future release. You may actually have conditions indicative of a release, but still, you conclude that you've got a wreck. So kind of going a little bit further with this example, what if the soil that was around this tank that has been contaminated, was capped with a geotextile fabric? That this cap and this fabric, must be inspected on an annual basis. You may conclude that you have a recognized environmental condition, but it's a controlled one. A controlled recognized environmental condition has been addressed to the satisfaction, of the regulatory authority, as evidenced by the issue of a no further action letter. But there's some controlled language in that, that's usually recorded with the property deed. And so there's some ongoing obligations from you as a potential future property owner or the existing property owner to make sure that cap's integrity, remains in place. And then lastly, as an example, using this, if you've got this stained soil and it was completely removed and not capped, and then you took some samples from the base of that excavation and those samples showed that everything was clean, you might conclude that you have a historical recognized environmental condition, which this has been addressed completely to the satisfaction, of the applicable regulatory authority, or it met unrestricted use criteria, established by that same authority without subjecting the property to any required land use controls. Got, a couple pictures I was going to share to kind of illustrate some of these points. So, these are the tasks at hand when completing the phase one ESA. Is there a reason, again, to be concerned about the environmental integrity of this specific piece of real estate at this point in time? Here we have in this picture some heavily stained soil along the building foundation. We also have evidence of poor housekeeping with the presence of unmanaged debris strewn about. This, to me, may be evidence, that's clear. It's conditions, indicative of a release. Or kind of using that hemorrhaging tank example, we spoke about a couple of slides ago. At first glance, you might think this tank is okay, but if you look closer at it, you see that the right side is just short of being punctured by its underlying cinder block foundation. While nothing from the tank has gotten outside, you might, view this as a material threat of a future release. And so it's still a recognized environmental condition, even though the contents of the tank might still be in the tank. And as a third example, here are numerous drums, under this warehouse, this open air warehouse, all of which, seem from this picture at least to be in good shape. They're labeled. Some in the front are on secondary containment. And so while these drums might store, some of the nastiest chemicals known to man, they're in good shape. There's not necessarily a threat of future release. There's no evidence of a release from any of the drums, and so this might not be a recognized environmental condition at all. But to tie this all up, or to tie at least the phase 1 environmental site assessment portion up, phase 1 ESA is conducted to identify liabilities associated with potential or existing environmental contamination. Remember, you're evaluating whether you have recognized environmental conditions, as defined by the ASTM standard. So not only can contamination impact property value, but having visibility on this issue, it also allows for potential landowner defense once that entity takes title of the property. So you have to go through all these steps. You have to issue your report to basically say, here, I complied with EPA's all appropriate inquiries. I conducted a phase 1 that's consistent with the latest ASTM standard. And so I'm innocent. I didn't know this was here, or I knew it was here, but it, appeared to be addressed to satisfaction of the applicable, regulatory authorities. And so, that document, that phase 1 report, that's your liability protection. So, Katie, did anyone submit any phase 1 related questions? Now might be a good time to kind of go through that.
I do not see any questions.
Okay,
Yeah.
Great. We'll moving on. So in addition to federal liability protections you receive by conducting, phase 1 ESA, you can also receive state liability protections in the form of a Brownfields agreement. So what is a Brownfield site? Well, by definition, it is an abandoned, idled, or underused property at which expansion or redevelopment is hindered by actual environmental contamination or the possibility of environmental contamination, and that is or may be subject to remediation under any state remedial program, or that is or may be subject to remediation under CERCLA. So a couple of interesting keywords there, or the possibility. You don't actually have to have documented contamination to get into the Brownfields program. Phase 1 ESA, that shows you're next to a site that does not, that does have contamination might actually be enough to get you in. And with more and more attention being paid to urban infill development, this is a welcome, ambiguous phrase for those that are developing land next to a gas station or a dry cleaner or, an old city dump, as an example. So the North Carolina Department of Environmental Quality, of which the Brownfields program is in or under, has multiple divisions. There's an air quality division, coastal management division, a water infrastructure and resources division. But the one that mostly applies to the type of contamination we are discussing today is the Division of Waste Management, of which the Brownfields program is one of 5 separate subset programs. So why should someone consider going into Brownfields, assuming they have a choice? In other words, they are not buying a Brownfields property, and so they're inheriting whatever comes with that. Well, in short, it's to get liability protection and tax incentives. According to the statute, prospective developers shall not be held liable for remediation of areas of contaminants so long as the activities conducted on the Brownfields property do not increase the risk of harm to public health. This is a big deal. The state is basically saying, go ahead, buy this property, and then enter into agreement with us. And under that agreement, we will not make you clean up the contamination, but we will, however, partially own this contamination. And because of that partial ownership, we're going to ask that you make it safe for whoever is using it, not to remediate it necessarily, but to make it safe. And the second benefit of the Brownfields program is tax incentives. This incentive comes in the form of a property tax exemption, which occurs on a sliding scale for a total of 5 years. However, it's only applied to capital improvements. It's not the entire property value. It's the delta of the improvements that are made on it after agreement has been executed on it. It can be transferred to future property owners. So if you could buy a property, go through the Brownfields program, not develop it, but decides not to realize those tax incentives and defer them to a future owner, as part of a marketing ploy. As an example of how substantial these tax benefits can be, this breakdown shows that this capital improvement that this project made resulted in a 1 million net value on this property. And so when you break that down into 5 different years on that sliding scale, it comes out to about $25K in cost savings on that property tax. So the program has drawn a lot of attention in the last couple of years. To date, well, as of December 1st, 581 agreements have been finalized, and there are over 200 active projects currently underway, with almost 20 of them actually waiting eligibility to get into the program. Like a lot of state entities, they're overwhelmed trying to keep up with demand. And so I think, as I understand it, they are hiring some new folks to kind of get things back to a more manageable level. But a lot of people are certainly taking advantage of this program. Here is a map from the Brownfields program website that shows mostly downtown Raleigh. And you've got Dorothy Dix Park down here, and all these color-coded parcel outlines are Brownfields properties. So they mean different things. Blue, I believe, means that it's in the program, does not yet have an agreement, whereas I think maybe the green means that it's got one, or that might be this purple up here. But you can see that, downtown Raleigh, you throw a rock on Glenwood South and you're going to hit a Brownfields property. So, once you decide that you want to proceed to go into the program, you've got 3 main options. The more widely used option is this middle one, this redevelopment now track, where you would pay $30,000 to get into the program. Before, we were seeing that you could get in and get an actual agreement within 12 months, but just because of how busy everything has been, this 12 months might actually look more like a 24 plus month timeline. If you don't want to pay the $30,000, or you're not in a rush, you could go the standard route, which was the older way that a lot of people did this, with just ultimately an $8,000 fee. And then the third one, this ready for reuse, you could actually have contaminated the property, but you wanted a Brownfields agreement to use as a marketing ploy. And so you pay $15,000, you take it up through the almost finished Brownfields agreement, but instead of you finalizing that agreement, a prospective developer you want to sell the property to actually takes it from there. So you don't realize the tax incentives, the person that you're selling the property to, but that's another option that's not so widely used. So regardless of the 3 options that's chosen, there are 4 main steps to completion of getting a Brownfields agreement. Regardless of which track that you use, these steps are necessary before the state will actually execute the agreement, which is ultimately the document that ties them and you to the contamination on the site. And because of this, they will in turn want information and data from the developer and their team. So collection of this information comes at a cost, which in some cases may actually outweigh the cost benefits of the tax incentives. And so this is an important note to make here, as some projects may not stand to gain by going through the Brownfields program. They might actually have to pay more money, but if getting that liability protection is more important, then that's something that just needs to be evaluated at the early stages of the development process. So step 1, actually applying to get in. The developer, and they're called the prospective developer, they provide information on their parent companies, any affiliations. They describe where the site actually is, what they want to do with the property. And this last bullet is pretty important because the state wants to see this. Not only are they developing the property to turn a profit, but what are they going to be using it for? Does the public benefit from this property at all? And if so, describe that. Is there an increase in local jobs? Is the tax base going to be increased? is this an old gas station that nobody wants to touch? And so because you're going through the Brownfields program, this gas station turns into a playground for the benefit of the residential properties that may be in the area. So step 2 is collecting these samples that often come along with developing a Brownfields property. So once you get into the program, you meet with the state. You show them what has occurred on the property, through maybe presenting them with your phase 1. And then you kind of target some sampling, soil, groundwater, surface water, sediment, and even like vapor intrusion related samples, and to get a better understanding of what's there if these samples haven't already been collected. So to kind of wrap out or round out, that second step, you also need to prepare an environmental management plan. This is more or less a construction document that can be used by your general contractor or your grading contractor that describes what you can and can't do with the dirt or groundwater. You could also evaluate whether vapor intrusion is a concern, which is what Greg's going to kind of get into for this last part of the presentation. That would entail preparing a vapor intrusion mitigation system plan. That might mean the new building that you want to build has to have some kind of engineering controls constructed within it to make sure that the site is safe. And then lastly, this final grade sampling has to occur. Once you've moved all the dirt, you've installed your hardscapes, your softscapes, you go out and collect another round of samples to make sure that you haven't brought any contaminated dirt to the surface. And so now it's just kind of sitting there unbeknownst to anyone. Step 3 is the state provides you with a draft agreement so that you can kind of review the language, specifically the land use controls that they might want to put on your property. And so this really is more or less a negotiation. Some of these land use controls are the state might not budge on, but others I've seen that they could possibly have some flexibility on. As part of the agreement, you'll have to have a land survey plat that shows where the boundaries of the Brownfields property are, and you'll also have to have this Exhibit 2, which shows any contamination that you're planning to leave on the site. So again, the Brownfields program does not make you clean up everything, but it just wants you to make it safe. So if you're going to leave contaminated soil on site, that might be okay, but this plat and this Exhibit 2 show exactly where that contamination stays. And then finally, step 4, to get a Brownfields agreement, you've got to go through this public comment process where people, specifically those that might be landowners in the vicinity of the Brownfields property, get a chance to comment, which doesn't actually often occur. And then once that public comment period, that 30-day process ends, then you can actually file the Brownfields agreement. So once you have one, or if you bought a property that has a Brownfields agreement, you do have some ongoing requirements as a landowner, and these are in perpetuity. If you're developing the property every year, you've got to submit these annual redevelopment summary reports. And regardless of whether you're redeveloping it or not, at the end of every year, you have this annual land use restriction update. So these are all the land use restrictions that are filed with the agreement and that run with the property deed that you as the owner or the owner 10 years from now have to check the box and say that you're in fact compliant, with every single one of them. And if you're not, what are your intentions to get back into, good graces with those compliance standards? And that kind of, briefly summarizes the Brownfields program in a very short, time. I want to go back to an earlier statement I made where I described that, the Brownfields program, as a state agency, is in fact, a partial owner of the contamination. There are absolutely trade-offs and costs associated with seeking state liability protection under a Brownfields agreement. And as with, having a partner for any type of development project, you're likely faced with evaluating the pros and the cons of that particular relationship. As an example, if you stand to realize, $100,000 in property tax incentives as part of your deal, but you also expect to export, 20,000 cubic yards of soil due to the site's grading plan, you may very well end up spending all of your tax benefit disposing of brownfield soil at a permitted landfill. or you have a balanced site, and so you don't have that problem. Or as a last example, you may need a vapor intrusion mitigation system, in order to make the site safe for its intended use. So before I kick it over to Greg to discuss that latter component with vapor intrusion mitigation systems, Katie, did anybody submit any questions?
Yes. Is there a minimum size threshold, for example, acres, to qualify for the NC Brownfields program?
No. That's the easy one. No,
Okay.
not at all. It does not matter.
We've got a few more. Are there any different rules for the Brownfields program when the owner is a local government, such as a community college or school district?
There should not be. If they're the responsible party that, is trying to get I shouldn't say responsible party. If they are the entity that's trying to get a Brownfields agreement, they play by the same rules, or should play by the same rules as a private developer doing the same thing.
Right,
now, they don't stand to, sorry, I just want to clarify, they don't stand to gain on the tax incentive because they don't pay property taxes. But the rules of the game are the same.
Okay, and last question, has activity in this program been increasing?
Absolutely. I feel like, talking to some of the state project managers, that they're just having trouble keeping up. I showed that slide with how many finalized agreements there were, over 200 sites that are currently in the program, and you might have 10 or 12 Brownfields project managers trying to funnel all these sites into the program. So it absolutely is increasing, from what we've seen almost on a quarterly basis, it seems like.
All right, that's everything.
Great, thanks everyone. I'll turn it over to Greg.
All right, thanks, Justin. Can everyone see the presentation? So yeah, we wanted to add an engineering component to the presentation because we're talking with PENC. So I'm going to discuss vapor intrusion mitigation. It's often a large part of the Brownfields projects that we work on. And if you're not familiar, vapor intrusion is essentially when vapors from contamination in soil or groundwater volatilize and migrate through the subsurface and can get into buildings, creating unacceptable indoor air concentrations. As Justin explained, the purpose of the program is to make properties safe for reuse. So sampling data may indicate vapor intrusion is likely or could potentially be an issue in site buildings. The Brownfields program may require mitigation if risk levels are exceeded, or long-term vapor intrusion monitoring if it's close and mitigation is not installed. So developers tend to prefer known costs versus unknown costs, so they often choose to mitigate buildings even if risk levels are not exceeded to avoid long-term monitoring or the possibility of vapor intrusion issues in the future. It's obviously much cheaper to mitigate during construction versus retrofitting post-construction. You can mitigate all types of buildings from residential, commercial, mixed use, industrial. Each has their own nuances and challenges. You can also mitigate existing buildings or install mitigation measures during construction. For the purposes of this presentation, I'm going to focus on new construction, but I'll touch briefly on existing buildings as well. Existing buildings present some additional challenges. Obviously, you don't have the luxury of installing a sub-base gravel layer with vent piping below the slab. So what you typically do is perform a pilot or influence test prior to design to determine the radius of influence and vacuum requirements to mitigate the area. This involves coring holes in the slab, applying a vacuum at that point, and at various vacuum levels, and then measuring subslab vacuum at various distances from that suction point. And you can have high variability in subslab conditions within existing buildings, as well as variability in radius of influence even within the same building. So I've seen greater than 40-foot radius of influence in one area and then next to nothing in another area of the same building. So you need to investigate what the building subgrade features are, whether the slab was poured directly on a clay layer or if there is a gravel layer. What are the foundation features? Are there footers or pits that could cut off flow? Are there preferential pathways such as cracks or utilities that could lead to short circuiting when you're applying a vacuum? Ground penetrating radar can be a useful tool to identify some of these foundation features. It's important to review aerial photographs and drawings if available to determine if additions were made to the building that may indicate differences in foundation features. Typically, you need higher suction fans to achieve adequate radius of influence in existing buildings, unless there's a gravel layer present. In some situations, if the influence is so low, it may make sense to just rip out the slab and install a system with a gravel layer and vent piping as if it was new construction. Here's just a couple section details of what a suction point might look like with a gravel pit connected to a riser pipe. And then if there's poor influence, you may need to install a trench filled with gravel and some slotted piping connected to a riser to create influence and mitigate certain areas. So some of the components of a vapor intrusion mitigation system is the subslab gravel layer and a vent piping network within that layer to allow vapors to travel. A vapor barrier below the slab to prevent vapors from intruding into the building. Riser piping coming out of the slab connected to your subslab vent network to exhaust vapors to the roof. Monitoring points throughout the building footprint to measure vacuum to confirm you're able to achieve influence across the building, as well as collecting subslab soil gas samples following installation. And then finally, connected to the risers at the roof, you need a fan to create a preferential pressure differential to draw vapors out, and those can be active or passive. So the first components are the subslab gravel layer and vent piping. The gravel should be washed clean gravel with no fines, so there's no restriction in flow. Typically it's 57 stone or pea gravel. And then for the vent piping, often it's PVC piping, slotted or perforated in areas where you want to mitigate, and then solid in areas where you're going through foundation features. And you got to make sure the piping size is appropriate so you're not restricting flow. There's also other vent options, low profile vent systems. The top left photo is GeoVent by Setgo. Land Science makes another similar product, but it's a low profile egg crate structure with similar characteristics to 4-inch pipe. So it allows you to apply a less thick gravel layer, but the manufacturer may require that you use their spray applied barrier with certified installers. So there could be some costs with that as well. And then the bottom photo is a Cupolex system. It offers great preferential flow because it's open underneath the floor slab to provide a pathway for vapors, but it also can be expensive and unfamiliar to builders. PVC and gravel are typically installed by the plumbers and concrete contractors already on site, so there's no additional contractors needed, and they're familiar with those materials. For your vapor barrier, you can use taped sheeting barriers, or there's also spray applied barriers. All are rated for volatile organic compounds. The tape barriers are installed typically by your concrete contractor that's familiar with installing those barriers. And then the spray applied barriers are typically installed by specialty contractors that need to be certified by the manufacturer. So you have a new contractor coming on site just for the barrier. It can be easier and get a better seal when you are using spray applied barriers, but we've also had success with tape barriers in achieving the necessary specifications. It's important to seal around the penetrations, make sure that there's no ability for vapors to come through the barrier. Oftentimes, we'll smoke test the barrier to make sure that there's identify any penetrations in the barrier that may need to be sealed. This there's a video just showing kind of what the smoke testing looks like. Obviously, they have some work to do there. And there's also hybrid barriers where there's a tape barrier or a sheeting barrier, but all the seams are taped. Or I mean, all the seams are spray applied, so it's kind of a hybrid approach. Next would be the riser piping. So the spacing and locations are important so that they're out of the way, but also in positions able to mitigate the entire building footprint. Developers typically want these hidden within the walls, so we need to work with the architect to make sure that they're in okay locations. Risers need to be appropriately pitched, so you're preventing condensation water from clogging the lines, and so they drain to the slotted sections of the subslab piping. And again, appropriately sized depending on the piping length and the area to be influenced. So taller buildings may require larger diameter piping. Monitoring points, these can be just PVC, connecting the gravel layer just above the slab with a plug and a clean out, or vapor pins, which you see on the photo on the right, which is sealed in the concrete, so that you can collect vacuum measurements throughout the building footprint, but also collect subslab soil gas samples. And then finally, connected to the riser on the roof are fans. These can be anywhere from inline radon type fans, as you see in the photo in the middle, to industrial blowers, manifolded with multiple suction points. We've had success with inline fans providing sufficient influence with less maintenance and low operating costs, especially for new construction with suitable subslab vent networks. High flow, low vacuum fans tend to be adequate with a permeable subbase, like a gravel layer. For existing buildings where higher vacuum is needed, you may need an industrial blower setup, or there's also now inline fans that can pull up to 25 inches of water column that can operate on a DC current that's converted at the fan, which is a new fan type that seems to be promising. And you can also install alarms or telemetry on these fans to provide notifications if vacuum's lost, to send someone out to correct the issue. And then these fans can also be passive wind-driven turbines, as you see in the photo on the left. Once the subslab vent network's installed and the slab's poured, you want to do a pilot influence test. Essentially, you're inducing vacuum at the riser pipe as it's stubbed up, and then measuring vacuum across the building footprint at your monitoring points. For the Brownfields program, they specify 4 pascals or 0.016 inches of water column, considered to be adequate vacuum throughout the building. You see a manometer here measuring the vacuum influence at a monitoring point. Here's just an example layout at a student housing building. You see in gray the thickened slabs, the riser pipes in red, dash green is slotted piping, red is solid piping going through these thickened slabs, purple and blue are monitoring points. So a pilot test would be applying a vacuum at this riser point and measuring vacuum throughout the surrounding monitoring points to confirm that you're able to achieve vacuum across the building footprint. Here's just an example of the variability in the subslab vent network. So on the left is a hotel building that had rib beams going vertically on the image here that would separate it out, influence across the building footprint. So you had to have vent networks throughout to make sure you're able to achieve vacuum throughout the building footprint. Risers are hidden within walls. Elevator pit was a challenge to seal around. And then on the photo on the right is just an open warehouse building with monolithic slab, no foundation features that limit flow. So you're able to space the risers out much further than you would in this scenario on the left. I think the spacing here was about a riser per 7,500 square feet, where on the left it was 2,000 square feet. So just something to consider. Obviously, the sub-slab foundations affect how your vent network's laid out. And throughout the whole process, you need to perform inspections and testing. You need to inspect the gravel thickness, the piping's in the correct locations, it's slotted where it needs to be, it's solid where it needs to be, monitoring points are present, and riser pipes are in the correct locations and appropriately pitched to drain properly. Need to inspect the barrier to make sure it's sealed around penetrations into the footers. And then each step needs to be signed off that it was constructed per the design, and then a sealed installation report is submitted to the Brownfields program. Communication is critical throughout this process so that we're notified when we need to do these inspections. Oftentimes we'll get notification the day before there are concrete trucks coming on site that we need to get out there and inspect the barrier. So the better the communication, the more heads up we have to get everything inspected appropriately. On the left, just an inspection checklist we provide builders so they're aware of what the steps entail, so everyone's on the same page. We'll do a kickoff meeting prior to the building construction so that everyone knows what to expect. If subslab soil gas results exceed risk levels, we proceed to indoor air sampling. And then if indoor air results are unacceptable, we may need to switch from passive to active fans. Some of the key points, early coordination with architects and structural engineers is important so that you can understand where utilities are, where the risers can be located, what foundation features will be present, and how to tie those into the barrier. Based on sub-slab concentrations, you need to tailor your system to site-specific conditions. So if sub-slab concentrations are lower, a tape barrier could be adequate. If it's highly contaminated, you may want to go with a more robust spray applied barrier. You don't need to install the Cadillac of systems at all sites if the conditions don't warrant it. You need to, like I said, tailor your system to be site specific depending on what the foundation features are and the concentrations are, and what the use will be if it's residential versus an industrial facility. Also, you need to consider what the installation costs will be, as well as the operating and maintenance costs. Typically, we start with a passive venting system with the option to activate to reduce costs. If a vapor intrusion sampling post-construction is favorable, then you don't need to activate a system. And then the final bullet, communicate. Like most projects, they run much more smoothly when there's an open line of communication throughout the process. And so that's all I've got. I just wanted to go high level on this mitigation system. And if you have any questions, I'd be happy to answer them.
All right, while people are typing in their questions, we've got one more poll question that will pop up on your screen. So go ahead and participate that. The question is, have you participated in the North Carolina Brownfields program? We'll give everyone a couple more seconds to get your answers in. All right, and the results there, 18% say yes, I've participated, 82% no, I have not. And we've got a couple of questions. Do elevator shafts, especially clusters of shafts, require a separate VIMS piping setup, or can they be sealed out to be excluded from the building footprint?
So how we typically handle elevator pits is we do have a barrier under the pit itself, and then depending on the situation, we may have piping underneath. But for the most part, we've had success just with the barrier. And some of the manufacturers, if it's a spray applied system, have details on how that's installed.
All right, what requirement is there to notify occupants that the facility they are inhabiting requires this level of mitigation?
Justin, do you have an answer for that? I'm not aware of a requirement.
Yeah, I think that's correct. There's no requirement that's spelled out anywhere that I've seen, but it kind of falls under the decency of humans kind of thing. So, or any contractual obligations you might have with your tenants.
All right, that's all of the questions. Justin and Greg, thank you so much for your time today. If anyone on the call has additional questions, you can see their contact information on the screen there. Your PDH forms will be emailed out to you later today. Our next session of the Raleigh seminar will be at noon, and that is an update from the Board of Examiners on board activities. Justin and Greg, thank you again, and we will see you all shortly.
Thanks, Katie.
Thank you.